Hello students, welcome to CBSE Science Series. Today we are going to learn about Coulomb's law. We know there are two kinds of charges, positive and negative. Now we try to understand what are the forces between the charges and how does the force depend on the distance of charges and magnitudes of charges. In 1784, French scientist George Augustin de Coulomb did number of experiments to find out how does the charges vary based on the separation. He took a pair of identical charges to measure the force. First, he kept magnitude fixed and varied the separation between the charges and kept separation fixed for various magnitudes of charges. This is what Coulomb's law, and Coulomb's law tells the force between two point charges. What do you mean by point charges? The size of the charges is very small compared to the distance between the charges. That charges are known as the point charges. Consider two point charges Q1 and Q2. These two charges are separated by the distance r, and these two charges are like charges, that is positive and positive or negative and negative. The force between the charges is repulsive force. These two charges are unlike charges like positive and negative. The force between the charges is attractive force. This attractive and repulsive force between these two charges is directly proportional to the product of the magnitudes of two charges and inversely proportional to the square of the distance between them. This is what Coulomb's law. How can we represent this Coulomb's law? This way we can represent the Coulomb's law. See, this is the charge Q1. This is what the charge Q1, and this is what the point charge Q2, and this is what the distance between the charges Q1 and Q2, and the force between the attractive repulsive force between these two charges directly proportional to the product of Q1 and Q2 and it is inversely proportional to the square of the distance between them. If you combine these two, F directly proportional to Q1 and Q2 divided by R square. And if you want to remove this symbol, we have to put one constant, that is K. F is equal to K Q1 Q2 by R square. K is a proportionality constant and it depends upon the medium, and its value is 9 into 10 to the power 9. Its SI unit is Newton meter square Coulomb to the power minus 2, where epsilon naught is the permittivity of free space and its value is 8.854 into 10 to the power minus 12, and its SI unit is 10 to the power minus 12. Its SI unit is Coulomb square Newton to the power minus 1 meter to the power minus 2. If you consider these Q1 and Q2 are 1 coulomb of charges and it is separated at a distance of 1 meter in free space, the force between these two charges is 9 into 10 to the power 9 Newton. Or you can say this way, 1 coulomb is the amount of charge that repels an equal and similar charge with the force of 9 into 10 to the power 9 Newton when placed in vacuum at a distance of 1 meter from it. This is what about the Coulomb's law. Thank you.